Welcome back. Now that we have seen how to start an Apache server HTTP instance where that our IBMI can sit and listen for our APIs to be called from a consumer and from a distributed environment off platform, let's look at building our first API. So we will go into login. When we log in here, what you're doing is you've already installed the save file to your IBMI, and you're going to access that information in CoreiRST library from a GUI environment. We will, for my sake, access my environment, and in we go, and we see at a glance when we first get in, it loads our API library, the version. HTTP non-secure is not listening. That's fine. Secure HTTP server is listening on our LPAR that we have targeted, and we are ready to create a new one. Just take a glance and see what all's here. Yeah, I've got a lot of miscellaneous things in my library that you will not see in yours. Let's create one. Just do create, and then we will give it an API name. The first thing it needs is obviously an API name. It's gonna assign the next like 10 character IBMI object name. It'll pull that itself, but we will define where it goes in the library, what source file, library, and source file itself the generated code will go into. But this is just a name for it, and we like to use the kind of a camel case, something that's very descriptive and that fits the purpose of exactly what the API is going to do with a version on the end of it. This way you can easily roll out new versions of this particular API if you need to. There's different strategies on how to do versioning. We like this way. So we're going to put it in the CoreiRST object library, and we will do the CoreiRST source library as for the library. And for the source file, we have one on our system called CoreiRST_s. You probably have something like QRPGLA source, something like that. That's fine. Any library you want to put it in. So with this particular API name we gave it, it fits a default structure of an API that comes up by default in add mode. And we're going to spend a little bit of time on this because this is important to understand this. Obviously, any HTTP web service API REST can accept any JSON request in any format, layout, structure, or whatever. For the CoreiRST product, it is mandatory that we do have a command, an environment, and payload in the root of our request. The command is obviously what we see here, the name of the API. The environment is a 3-character code that's going to relate to a library list. So let me pull this up and kind of show it to you. If you go into your LPAR, let's see, let's go in. We will look at this library list that I'm talking about. When you go into option 1 and hit F7, you're presented with the ability to define a library list that relates to an environment. And that environment right here is going to correspond to the one in the request that's sent. And what that allows us to do is simply say, look, load this library list for this API call. This is helpful in change management in the software development lifecycle. Let's say you're developing a development, then you want to roll it up to QA, then you need to get it into prod. Each time you'll just give it a different environment name, and it will automatically set that library list for you. Instead of having to bang your head against figuring out what job descriptions load in the library list for you, this and that, relying on configurations of the different environments, that's good and all, but sometimes the flexibility and just having things just very, very simple works good. If we look at something called let's look at lot. This is one I have. It's for a particular application. Actually, lot. I need to add lot. So for that one, it would be that and CoreiRST, and that's going to help provide a library list for any APIs that are called for that particular type of application. There is an ADM one right now, and it loads these libraries right here. And so that I just wanted to show you that and how that's configured into this. I think it's a very good, easy feature that's helpful in determining library lists when you call your APIs. Secondly, the payload. The payload's going to be literally the bulk of your request. It's going to be an array, and it's going to be a repeated object array where you can send multiple entries of something in. A lot of times, it's mostly just going to be one particular object that you want with a whole bunch of different keys and elements in it to provide as a request. But you may have, iterative payload objects for different requests for different requests. So this is just a demonstration of the different types of keys to give an example of what the different data types may look like. So we will stick with this and hit continue. And it's going to parse this for us. The request is, let me back up maybe and say, if you created a request here, well, let's just say if we do something invalid and continue, the backend's going to check. It's going to say, hey, this JSON request appears to be invalid. You need to fix this. It's not going to let you go forward, obviously. So just hit go back and you can fix it. But if you stray from this particular structure, the parser will not be able to accurately parse out the key values for you. But our recommendation for that, to get around that, is to at least start with something the parser can easily parse, get a compiled object and generated source code, then get into the program itself and start enhancing it from that perspective, because you have a lot more to work with at that point that's automatically been created for you. So we fixed our error. We're moving forward. It shows us the JSON stress string. It shows us in a pretty format. And now it's extracted those keys from that structure that it knows how to parse. We want to set our max values here, the max of what we'd expect ever to receive in any of these guys. Let's just increase this one out to, say, 70. Everything else, I think, looks right. Key numeric is 10. It calculated 10 length for that. Timestamps 26. That's typically the case. We'll leave that. 14.4 is what it pulled for this value. We won't expand that. We will say that we always want these values to be sent to us from the consumer. Let's just take a peep in some of these guys to see what our options are. Char, varchar, zoned, date, timestamp. And if we get into needing to receive very large strings of information, we have CLOBs defined up to 5 megabytes. We can easily enhance this. IBM DB2, I think, can support up to 2 gigabytes. For our needs, this is all we've ever needed, but we can easily slap in higher amounts if we need to per requirements. Gives us an example of what that value may look like. That's very good for Swagger purposes and documentation. It just pulls it from your example request. Enum values, like say if you have an array of different values in comma delimited format that you want to specify and say only these values can be accepted, it will check that as well. We can enhance this more as we need to, but that's pretty satisfactory and standard for right now. We will hit accept key attributes, and it's going to, what it just did right now, is it went out and it generated your source code in the library and source file was specified. It compiled the object with exactly the source, and yeah, that's it. It did it. It created it, and it assigned the next API name. It's always going to increment the API name to the next one in that library. If there are no API program source members in there, or program objects, should I say, it's just going to start with 1, and it will increment. Therefore, that's how it defines the naming. And so now it's, if we go back to our list, your new API program should be in there. We'll just kind of skim through here and look. Again, I have a lot of things. There it is at the bottom. Your new API program was created. let's test it now. Okay, so since we're on an external server outside of the IBMI, the only way to get the things over there is through HTTP. So let's do a test. Test, and it's going to pull up that particular API name and library. We no longer have to go out to Postman to do this. You can if you want, but it's built in here to the product. It's going to show you your request. You can modify the values here. Obviously, if you change the request, it's not going to be the same specs as the expecting API we just created. So, but you can change your values here. And let's do that for demonstration sake. So let's just say, let's change this to JAY. And let's consume it. Called it, pulled it back. Here's your response. It's basically just going to, like these default APIs that we create and generate, the response is just defaulted to exactly what the request looks like. So we can get a API in place so you can later on go into it and formulate your true response, slap in your particular program or whatever you want to call to generate your response. But just to get something up and working, we use the request itself. And there's a reflection of that successfully returned to us. And we can go back and we can test it again with some more values. But I think we're good. So let's just consume it again and see. Okay, back to API list. So it'll take us back to the API list. Last thing we want to look at real quick when we create an API is the Swagger and how easy it is to get documentation for it. Super simple. Hit the Swagger button. It's going to pull up all the information and metadata that needs to be in a open API Swagger document. It fills in everything default that should probably be there. You have the option of changing some of these things, not everything. But let's go ahead and give it an API description, and we'll just say it's our new demo API that returns the request. Okay, and update Swagger information, create the Swagger document. It's going to update the information for that Swagger information on your IBMI system and generate the open API Swagger document for it. All right here, ready to copy and paste out to give it to your MuleSoft team, your Gateway team, whoever your consumers may be that need this document to consume your API. I think that is all when you create a new API. You can do it very quickly. The main things to remember is it's set up to be quickly automated, where you can quickly generate a source and get an object, something that's callable, something that's workable, that you can then go into and enhance more if you'd like to. And as far as generating those responses, let's do a quick look over here on the system at the actual source code that it created. That's a big part of this. Let's see, it's in here. It was the last one, 18, not that one. It was over in the REST library right here. You new API program. This is what it created for us. We'll go in and have a look. Here's your source code that compiled that we just called through the system. There are parameters here that it laid out for us that we defined and it extracted through the parser. Here it is through JSON. It's actually pulling those out through the JSON and putting them into host variable structures that we can work with. And then it's going through each of the payload objects. You know, we specified one, but if it had multiple, it would go through and work with each object that you had sent in the payload array, checking for different requirements. And then here, the get response procedure is the simple built JSON object return response based on the request. Right here's where you would put in a call to your program that's going to take the request data structure in, do whatever it needs to, fulfill a response, kick out the response data structure, and then you'd build the simple JSON return based on the SQL DB2 JSON things. There's no YADL here, so there's not that extra YADL RPG stuff you have to work with. Strictly DB2, it's much simpler, cleaner, and streamlined, in my opinion. That's the last thing I want to show you. Hope you enjoy it. I think it's quick, easy, and powerful, and all you need really to build web service APIs for your IBMI system. Thank you.